This is a trial video I am creating to help y'all on these lessons. If the feedback I get from you is good, I'll continue making these videos for future lessons. However, making videos like this takes quite a bit of time and effort on my part, so I'm not sure how quickly or easily I'll be able to create any potential future videos. I'm still very new to video recording and editing, so bear with me as I figure this out. For this first video, I will walk you through section 3.1 homework, graph linear equations in two variables. The problems I will be working are randomly generated and will most likely be different from your version, although there is a small chance you could get lucky and have the same version, but don't count on it. Feel free to leave comments with any questions you might have. Without further ado, let's get started. This first problem is very simple. It just wants to know which quadrant or axis each point is located on. If I go up and right-click, if you're using a Mac or Chromebook, click with 2 fingers to right-click, on the course title up here, I can open it in a new tab. Then if I switch to the new tab, I can scroll down and find the textbook link for this assignment. Click on that, click Next, and the first thing it gives us is a picture with the labels for each of the quadrants, the origin at the center, and the 2 axes. The y-axis is the vertical line, and the x-axis is the horizontal line, and the origin is the point where the 2 of them meet. You can also see how the axes split up the graph into 4 separate sections called quadrants. The first quadrant is in the top right section. The second is in the top left. The third is the bottom left, and the fourth is the bottom right. Just remember that the first quadrant is in the top right and then go counterclockwise to label the rest. If I switch back and forth between the tab with the assignment and the tab with the textbook, I can easily figure out which label goes with each point on this graph. Point A is in the top right, so it's in the first quadrant. Point B is in the bottom left, so it's in the third quadrant. C is located right in the center where the 2 axes meet, so it's located at the origin. D is in the bottom right, which is quadrant 4. E is located on the vertical line, which is the y-axis. F is on the horizontal line, which is the x-axis. And G is in the top left, which is quadrant 2. This second question wants to know the coordinates of each point on the graph above. Coordinates in math are called ordered pairs. It's made of 2 numbers, the x-coordinate, which tells you how far left or right a point is located, and the y-coordinate, which tells you how far up or down a point is located. Both numbers measure the distance from the center of the graph, which we just learned is called the origin. If you ever forget which letter comes first, remember the end of the alphabet, X, Y, Z. Alphabetically, X comes before Y. It's also important to know that each coordinate can be positive or negative. Positive X values mean you go right from the origin. Negative X values mean you go left from the origin. Positive Y values mean you count up, and negative Y values mean you count down. If the X value is 0, then you don't move left or right, you stay in the center on the Y-axis. If the Y value is 0, then you don't move up or down, you stay in the middle on the X-axis. It's very common to get the zeros mixed up. Just remember that if one of the points is 0, then it's on the opposite axis. My first point is A. I'm going to start from the center of the graph at the origin and count the number of squares I need to move to get to point A. Let's start by counting horizontally first to get our x-coordinate. I need to go left 1, 2 squares. Since I went left, the x-coordinate is -2. Now let's count vertically from that same position. I need to go 1, 2, 3 squares up. Since I went up, the y-coordinate is positive 3. So the coordinates or ordered pair for A is -2, 3. Next is point B. I'm going to start from the center and count horizontally again. I need to go left 1, 2, 3 squares. So the x-coordinate is -3. Now let's count vertically from that same spot. I only need to go down 1 square, so the y-coordinate is -1. This makes the coordinates for B -3, -1. Next is point C. I don't need to move left or right, so the x-coordinate is 0. I also don't need to move up or down, so the y-coordinate is also 0. This means that C is located at the origin with coordinates 0, 0. For D, I need to go right 1 square, so the x-coordinate is +1. Then I need to go down 1 square, so the y-coordinate is -1. This makes the coordinates for D +1, -1. Question 3 gives us 5 sets of ordered pairs and wants us to place the points on the graph for each ordered pair. We'll use the dot tool to place them. Remember, the first number is the horizontal x-coordinate, where right is positive and left is negative, and 0 is in the center. The second number is the vertical y-coordinate, where up is positive, down is negative, and 0 is in the middle. Our first coordinate is -3, 0. Since -3 is our x value. Since it's negative, we need to go left 3 squares. 1, 2, 3. 0 is our y value, and since it's 0, we don't need to move up or down, but stay in the middle and place our dot. Our second coordinate pair is -2, 4. -2 is our x value. Since it's negative, we need to go left 2 squares. 1, 2. 4 is our y value. Since it's positive, we need to go up 4 squares. 1, 2, 3, 4, and place our dot. The third coordinate is 1, -4. 1 is our x value. Since it's positive, we need to go right 1 square. -4 is our y value. Since it's negative, we need to go down 4 squares. 1, 2, 3, 4, and place our dot. The fourth coordinate is 0, -1. 0 is our x value, and since it's 0, we don't need to move left or right, but stay in the center. -1 is our y value. Since it's negative, we need to go down 1 square and place our dot. Our fifth and final coordinate is -1, -3. -1 is our x value. Since it's negative, we need to go left 1 square. -3 is our y value. Since it's negative, we need to go down 3 squares. 1, 2, 3, and place our dot. Question 4 is a bit different. It gives us several x values and an equation. It wants us to evaluate the equation for each of the given values. That means we need to plug in each of these numbers for x and simplify the equation according to the orders of operation and find out what y will equal. We can then use those coordinates to graph the equation on the graph below. In order to show you the work and how you plug these in by hand, I'm going to be using some tablet capture software and an art tablet to show you how I'm working these problems. So our first x value is -5. So we're going to plug that in for x, putting it in parentheses where x is. So that will give us y equals -4 times -5 plus 3. The first thing we're going to do is multiply negative 5 and negative 4. 4 times 5 is 20, and negative times negative means we get a positive, so we'll rewrite this as y equals 20 plus 3. 20 plus 3 is going to give us y equals 23. So I can type that in for my first y value. So let's box off our first bit. Our next x value is negative 2. So if we set that up, we have y equals negative 4 times negative 2 plus 3. First we multiply negative 4 and negative 2. 4 times 2 gives us 8, and a negative times a negative will be positive. So if we rewrite it, we have y equals 8 plus 3. Add 8 and 3, and we get y equals 11 for our next y value. And we can plug that in. Next, we have x equals 1. So let's box this off and start on the next one. Y equals negative 4 times 1 plus 3. Again, we'll multiply negative 4 and positive 1. 4 times 1 is 4. Negative times a positive will give us a negative. So we have y equals negative 4 plus 3. Now this time we're adding a negative and a positive. Remember to think of it like spaces on a number line. If I start at negative 4 and then move 3 places to the right, I will wind up at y equals negative 1. So that will be my next y value. For the last part, we have x equals 3. And if we set that up, we have y equals negative 4 times 3 plus 3. Again, we'll multiply negative 4 and positive 3. 4 times 3 will give us 12, and a negative times a positive will be negative. So y equals negative 12 plus 3. Again, we're adding a negative and a positive. So if we start at negative 12 on a number line and move 3 places to the right, we will wind up at y equals negative 9. And that will be our last y value. To set up the graph for this problem, we could use all 4 ordered pairs, but since it's a straight line, all we really need is just 2. So I'm going to use the last 2. I have positive 1, negative 1, and 3, negative 9. So to get to positive 1, negative 1 is our x value, so we move 1 to the right. Negative 1 is our y value, so we move down 1 and place a dot. For our next point, we start back at the center. X is positive 3, so I move 1, 2, 3 places to the right. The negative 9 means I move down 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I can go ahead and click Submit, and I get full credit for the graph, even though I only plotted 2 points. Question 5 wants us to determine whether each ordered pair is a solution for the given linear equation. What that means is if I plug in this x value and this y value into this equation, does it wind up equaling 9 or not? So let's open up a new page and plug them in and test it out. So if I set up with my first ordered pair, I'll have 1 times negative 1 plus 2 times 5 equals 9. And I want to figure out if this is a true statement or not. So let's start simplifying it. 1 times -1 is going to give me -1. 2 times 5 gives me 10. And it's supposed to equal 9. So -1 plus 10 does give me 9. And 9 equals 9. So this one is a solution for the given linear equation. Let's test the next one. So if I set it up, we'll have 1 times 0 plus 2 times 5.5, and it's supposed to equal 9. 1 times 0 will give me 0, and 2 times 5.5 will give me 11, and it's supposed to equal 9. But if I add these two together and wind up with 11 equals 9, that is not a true statement. So this is not a solution. Now let's look at the third ordered pair. If I set it up, I'll have 1 times 4 plus 2 times 2.5, and it's supposed to equal 9. 1 times 4 gives me 4. 2 times 2.5 will give me 5, and it's supposed to equal 9. And if I add 4 and 5 together, I get 9 equals 9, which is a true statement, so it is a solution for the given linear equation. Question 6 wants me to find the intercepts of the graph. If it's an intercept, that means that it's crossing the x or y axis. If it crosses the y-axis, it's a y-intercept. If it crosses at the x-axis, it's the x-intercept. And if it happens to cross at the origin, then that is both an x and y-intercept. If I look at where it's crossing the y-axis, I can see it's crossing right here. If you notice, it's right here in the center. Remember our rules for ordered pairs and figure out the coordinates. If you look, it crosses at the y-axis, which is right in the center. And if it's in the center, that means that the x-coordinate is 0. And if I count from the center, it goes up 2 squares, so my y-coordinate is positive 2. So the y-intercept is 0, positive 2. Looking at the x-intercept, it's on the x-axis. That means that the y-coordinate is 0. And to get the x-coordinate, I have to go 1, 2 to the left. So the x-coordinate is negative 2. So this is at -2, 0. If yours happens to cross halfway between 2, then it will be that number 0.5. So if it was halfway between -1 and -2, it would be at -1.5. Question 7 is just like question 6. It wants me to find the ordered pairs. This time, let's start with the x-intercept. If I look on the x-axis, it's crossing at one point right here. Since it's an x-intercept, the x value is the one with the number. And if I look, it's crossing exactly at 8. So my x-coordinate is 8. And since it's on the x-axis, the y-coordinate is 0. For the y-intercept, you can see that it's on the y-axis, which means that the x-coordinate is 0. And if I look at the numbers, it's crossing right at -8. So the y-coordinate is -8. On question 8, it gives us an equation in what's known as standard form. And it wants us to find the x and y intercepts just using the equations. Then it wants us to use those intercepts to draw the graph. Since the equation is in standard form, there's a really easy way to find the intercepts. All I have to do is just eliminate either the x or the y part of the equation and then solve for whichever variable is left. For example, if I want to find the x-intercept, then I eliminate the part with y. I just plug in 0 for y. So I'll have negative x plus 2 times 0 equals negative 2. Well, 2 times 0 is going to give me 0, so I have negative x plus 0 equals negative 2. The 0 can just disappear, so we have negative x equals negative 2. And remember, if there's not a number in front of x, you can assume there's a 1 there. So to cancel it out, I divide both sides by negative 1. These negative 1s will cancel, and I'll wind up with x equals positive 2. So for the x-intercept, x equals 2. So I can set that up as 2, 0. To find the y-intercept, it's the same process, but I plug in 0 for x instead. So I'll have negative times 0 plus 2y equals negative 2. Negative 0 is just going to be 0 plus 2y equals negative 2. I can drop the 0 and I just have 2y equals negative 2. To get rid of the 2 that's multiplying by y, I need to divide. So I can divide by 2 on both sides. These 2's will cancel, and I'm left with y equals negative 1. So the y-intercept will be x equals 0, y equals negative 1. I can then use those intercepts to draw it on the graph. So the x-intercept of positive 2, 0. Positive 2 means I go to the right. 0 means I stay in the middle. And then for the y-intercept, 0 means I don't move left or right. Negative 1 means I move down 1. And there you go. Our last question is similar to question 8. However, this one has a much easier way to work it, because the equation is in the form of y equals mx plus b, which is also known as slope-intercept form. In slope-intercept form, the number in front of x is your slope, and the number by itself is your y-intercept. So since the number by itself right here is 3, that means that my y-intercept is at 0, 3. Now remember that slope is also called rise over run. The number on top is your rise. That's how far up or down you go. The number on the bottom is your run. That's how far left or right you go. And negative tells you how you combine those. If it's negative, that means you're either going to move right and down or left and up. This is a lot easier to see when you look at it in context. So if I start with my y-intercept, it's at 0, 3. So I'm going to move up 3 and place my dot. So the negative slope means it's going to be slanted like this, either down and to the right or up and to the left. And I can use my rise and run to find my second point. So my rise is 3. And since it's negative, I'm going to go down 1, 2, 3. My run is 2, so I can go right 1, 2. And again, notice how it's a negative slope line. It's going down and to the right. I can place my point there, which is also my x-intercept. So my x-intercept is at 2, 0. And that's how you do section 3.1 homework, graph linear equations in 2 variables. Again, if you have any questions on any part of this video, please comment down below or come and ask me during class. I hope this video is helpful, and if there's a good response to it, then I will do my best to make more videos like this for future sections. So go try section 3.1 yourself, and remember to be safe, be smart, and try to make wise choices.